I'm going to show you how to draw Lewis dot structures for compounds. You should have your guided practice notes in front of you, and you should follow along with me. So the first compound that we're going to start with is going to be CH4. So the first thing you have to do before you draw the Lewis dot structure is we need to decide if this compound is ionic or covalent. So the first thing we're going to do is we're going to take and we're going to put a box around the first element. And then look at our periodic table and decide if carbon is a metal or a non-metal. Carbon is a non-metal, which automatically makes this compound covalent. And in covalent compounds, we are going to share our valence electrons. Next, we need to go ahead and draw out the Lewis dot structure for each one of our elements. So we have a C for carbon. Then we need to look and see how many valence electrons does carbon have. Carbon has 4 valence electrons. So we have 1, 2, 3, and 4. Then we need to determine how many bonds carbon is going to form. Since there are 4 valence electrons that are not paired up, that means carbon is going to form 4 bonds. Now let's do hydrogen. Hydrogen is going to have 1 valence electron. I don't know why I didn't change colors. There we go. It's going to have 1 valence electron. Since it has 1 valence electron, it is going to form 1 bond. Okay? And we have 4 of those hydrogens. So just keep that in mind. So the next thing we need to do is we need to go ahead and figure out which one of these elements is going to be in the center of our compound. The element that has, or the element that's going to form the most bonds will be the one that goes into the center of the compound. So that is going to be carbon, because carbon has 4 valence electrons. So I'll draw a carbon here. And I'm going to add its 4 valence electrons. 1, 2, 3, and then 4. Now we need to add hydrogen around carbon. So we have 4 of them. So we have 1, 2, 3, and 4. And we need to add in hydrogen's valence electrons. Now, since we are sharing electrons, the valence electron needs to be between the carbon and the hydrogen atom. So we have 1 there, 1 for that hydrogen, 1 for that hydrogen, and 1 for that hydrogen. This is the Lewis dot structure for methane, CH4. Let's go down and try another one. So the next one on our page is sodium chloride, NaCl. Again, we're going to start with deciding if this compound is going to be ionic or covalent. Put a box around the first element. Look on our periodic tables, and we see that sodium is a metal, which makes this an ionic compound. In ionic compounds, we are not sharing electrons. The metal is going to transfer its valence electron to the non-metal. So again, we're going to start by drawing out the Lewis dot structure for each one of our elements. So we'll start with sodium. We only have 1 sodium. We look on the periodic table and we see that sodium has 1 valence electron. Changing colors sometimes. All right, there's my 1. And if we add it to chlorine, we look on the periodic table, We find the valence electrons for chlorine, and we see that chlorine has 7. 1, 2, 3, 4, 5, 6, and 7. So I said that in ionic bonding we are transferring electrons. So the sodium, which is the metal, will transfer its electron to chlorine. To show that transfer, you need to draw an arrow from the valence electron on sodium over to the vacant spot on chlorine, or to the valence electron that is not paired up. Then we are going to redraw this. So we show the electron from sodium plus the ones chlorine already had. Now, we are not finished yet. In order to show that we are not sharing any electrons, we need to put brackets around the compound, or not compound, around the element that has all the valence electrons. So that would be our nonmetal. And then we need to go ahead and we need to add the charges that is going to be formed. Since sodium lost an electron, which is a negative charge, it is going to become positive. And since it was 1 electron, it'll be a +1. Since chlorine gained an electron, which is negative, it now has a negative charge. And now we are done with the Lewis dot structure for sodium chloride. Let's try the third one. Our third one is ammonia, NH3. Again, start with whether it is ionic or covalent. Box the first element. Nitrogen is a nonmetal, so this is a covalent compound, which means we are sharing electrons. So we'll start with the Lewis dot structure of each element. Nitrogen has 5 valence electrons, so 1, 2, 3, 4, 5. And how many bonds is nitrogen going to form? Well, since there are 3 electrons that are not paired up with something else, it is going to form 3 bonds. Then we have hydrogen. Hydrogen, again, has 1 valence electron, so there is its 1. We have 1 electron that is not bound to anything, so hydrogen will form 1 bond. Now we need to decide which element is going to go in the middle of our compound. The one that goes in the middle, again, is the one that will form the most bonds. Hydrogen will form 3. Nitrogen will form 3. Hydrogen will form 1. So that means nitrogen is going to go in the middle. Draw the valence electrons for nitrogen. Add the hydrogens around. Remember, we have to place them where the bonds are going to form. So hydrogen here, a hydrogen here, and a hydrogen here. Now add in the valence electrons between hydrogen and nitrogen to show the bond is formed. So there's hydrogen's valence one, there's hydrogen, and there's that one. And that is the Lewis dot structure for ammonia. Let's move on to number 4. Number 4 is going to be calcium chloride. Again, start with whether we are looking at an ionic or covalent, so box the first element and decide if it is a metal or a non-metal. Calcium is on the left-hand side of the periodic table, so we are looking at a metal, which means this is a ionic compound. An ionic, we are not sharing, we are transferring electrons. So So we'll go ahead and draw the Lewis dot structure for each one of these. We'll start with calcium. Oh, what is doing here, guys? Sorry. There's calcium. Calcium is in group 2 on the periodic table, so it will form, so we have 2 valence electrons. We're going to add the chlorine. And if you notice, we have 2 chlorines, so we have to add both of them. Draw the valence electrons for the chlorine. Chlorine has 7 valence electrons. 1, 2, 3, 4, 5, 6, 7. Same thing on the other one. Alright. Now, the calcium is going to transfer a valence electron over to the chlorine. Each chlorine will get 1 of them. So we have to show that by drawing our arrows. We have, we'll say this one goes over here to this one, and this one is going to go over here to this one. So then we will have we have multiple atoms, I like to kind of put the one in the center, like the metal in the center, but it really doesn't matter how you draw it. Right? So again, draw our valence electrons that we have. So each chlorine has its 7. And don't forget, we now need to add the ones for calcium. Since it is ionic and we are not sharing bonds, again, we must show that they are not sharing by adding brackets around the nonmetal, or the one that has all of the valence electrons. And since it's ionic, don't forget that we must include charges here. Chlorine gained 1 valence electron. Since it gained an electron and it's negative, that means it'll have a -1 charge. That would be both chlorines. Calcium, however, it lost 2 electrons. So since it lost electrons, it becomes more positive, and it's going to be a +2. And that is the Lewis dot structure for calcium chloride. Moving on, we'll go into number 5. We have potassium sulfide. Okay. Again, start with whether it is ionic or covalent, so we'll box our first element. Decide if it's a metal or non-metal. It is a metal, so that means this is an ionic bond. So this one should look similar to the last one that we had. We will draw the Lewis dot structure for each. Potassium, we have 2 of them, so we have to draw 2 potassiums. The number of valence electrons potassium has is 1, so 1 dot here, 1 here. Now we add in our non-metal, sulfur. Sulfur has 6 valence electrons. We'll draw 1, 2, 3, 4, 5, and 6. Again, ionic bonds transfer electrons, so you must show that. So this electron will come over to the lone electron on sulfur here, and this one will go over here. Draw our new structure. Include our valence electrons. Sulfur is the one that gets all of our valence electrons. Add the ones from potassium. It is ionic, so don't forget to put your brackets. Why are we not doing colors? And again, ionic ones must have charges, so you must indicate that. Potassium lost an electron. When we lose, we become more positive, so this will be a positive 1 charge. And the other one will also be a positive 1 charge. Sulfur gained 2 electrons, so it will be a -2. And that will be your structure for potassium sulfide. All right, let's go on to number 6. Number 6 is carbon dioxide. Again, decide whether it is ionic or covalent. So put a box around the first element. This is a non-metal. Non-metal means that it is a covalent bond. Which means we are going to share electrons. We are going to draw the Lewis dot structure for each element. So we'll start with carbon. Carbon is going to have 4 valence electrons. Yeah. 1, 2, 3, 4. We have 4 lone electrons, which means that carbon is going to form 4 bonds. Then we have oxygen. Oxygen is going to have 6 valence electrons. Oxygen has 2 lone electrons, which means it's going to form 2 bonds. Okay. So now decide which one goes in the center. Again, the one that forms the most bonds will go in the center. So carbon will form 2 and oxygen carbon will form 4, oxygen will form 2. So carbon must go in the center. Carbon. Place its 4 electrons. And then the oxygen will go on the side of it. We have 2 oxygens though, so you need an oxygen on each side. And draw its valence electrons. So we're going to go 1, 2, 3, 4, 5, and then 6. We'll do the same on the other side. Now I'm not adding an extra one to the center because there's no electron from carbon in the center to bond with the oxygen. So we have to leave it like that. Now you need to make sure that everyone is happy before saying that this is your final structure. So that means that there should be no lone electrons. If you look though, we have a lone electron here. Carbon has lone electrons, and we have no lone electron here, which means that this is not the structure for carbon dioxide. So we can move our valence electrons around to form bonds to pair them up. That way we have everybody paired up. So we'll move this guy into the center between oxygen and carbon and move this one from carbon into the center. We'll do the same with the ones at the bottom and redraw our structure. We now have two valence electrons from carbon in the center on each side, which means we have 2 from oxygen to pair with it, and then you cannot forget the other pairs. 1, 2, 1, and on the other side. We have no lone electrons left, which means this would be your structure for carbon dioxide. Go ahead down to number 7. Number 7 is aluminum fluoride. Aluminum fluoride. Alright, decide if it's ionic or covalent. Aluminum is a metal, so this is an ionic compound. Ionic compounds do not share their valence electrons. So let's get moving. Start with aluminum. Aluminum has 3 valence electrons. And then we have to add the fluorine, and we have 3 fluorines. So 1, 2, 3. Fluorine has 7 valence electrons. So we'll draw those here. 1, 2, 3, 4, 5, 6, 7. These are going to look the same. Since we are transferring electrons, you need to show that using your arrows. So we'll take 1 from aluminum over here, 1 here, and then 1 over here. And we will draw our new structure. Our valence electrons. Show our one from aluminum that they got. It is ionic, so don't forget we need our brackets to show that we are not sharing these electrons. Is ionic, so that means we also need charges. Fluorine gained that 1 electron, the electron is negative, so it must be a -1 charge on each. Aluminum lost 3 electrons, so it becomes more positive, and it'll be a +3. And that is your structure for aluminum fluoride. Let's go ahead and move on to our last problem. Our last problem here. Dinitrogen dihydride. And decide if it is covalent or ionic. Nitrogen is a non-metal, so this is a covalent compound. So that means we are sharing our valence electrons. We draw the Lewis dot structure for each individual element. We have nitrogen. Nitrogen has 5 valence electrons, so 1, 2, 3, 4, and 5. Hydrogen has 1. Also, don't forget to determine how many bonds will form. Nitrogen only has 1 valence electron that is by itself, which means it will form only 1 bond. The nitrogen has 3 electrons that are by itself, so it will form 3 bonds. Now, remember, the one that has the most bonds to form will be in the center of your atom. So we have a nitrogen, and we have 2 of them, because it says N2, so nitrogen and nitrogen, they both have to go in the middle. And we only have 2 hydrogens, so we need to put the hydrogens on either side of the nitrogens. Hydrogen, draw our valence electrons. So we'll start with nitrogen. We have one here, one, and then two up here. They all look the same. Now go ahead and add hydrogen's bond, or valence electron. Remember, we got to put it in the center to show that we are sharing them to form that bond. Go ahead, take a look and see if everybody is bonded. We have no more lone electrons. This one, we still have lone electrons here on the nitrogens, so therefore we have to form bonds. We need to move them to where they're going to pair together. And the only way that you can move them to pair together is if you move them in between the nitrogens. Didn't mean to go down that much. And we'll go ahead and we'll redraw it below. These two, one between the hydrogens, and we actually have four between the nitrogens now. And draw hydrogens. And that is the Lewis dot structure for dinitrogen dihydride. Now you need to go ahead and move on to your independent practice. If you need to reference this video again to help you out, please feel free to do so.